on to agenda item 5, the AIRS drive test results. Michael.
Speaking of the value of technical assistance grants, the AIRS radio frequency drive test is brought to you by the OEC through a technical assistance offering. The drive test was conducted over a period of 10 days between December 5th and 16th. Before the test, public safety agencies were made aware the test was going to happen because the test tones were going to disrupt the air system completely and totally in the region that they were testing. DPS was available to suspend the testing in case there was an emergency requiring the use of the system. Okay, so I'm not going to go into the details. This is available to you in the presentation. Basically, a test tone or trigger tone was kicked off at the top of the minute, 15 seconds, 30 seconds, 45 seconds, and then back again at the minute mark. Readings from the frequency analyzers were done on all 3 bands for 10 seconds of the 15 seconds that was kicked off by the trigger. And that's filled in the gaps there on the 10 seconds of every 15 seconds. So there was a lot of data being recorded on this. Oops. Can't go zooming past the schematic. We have a schematic diagram. Okay, done.
We're trying to make you feel at home, Scott.
That's right. That's right. All right, this is the load planning. All the equipment that was going to be required. The main issue here was how much power is all it's going to take. That's a rental van loaded to the gills, and they ran it off inverters. Even though it was December, they didn't need to use the heater. And there's the antenna arrangement. Okay, so for the results, what we did is to make it familiar, we've got in the Google Earth representation of the data, we did overlays that are the AIRS regions. So you can see the AIRS regions up here in Mojave, down south, and then also overlaid the computer-generated coverage maps that, and this is the same map that's actually in the AIRS SOP document. It's not the individual county, but it's the overall state level. All right. Now, if you look in this is actually the day 1 drive test. Went from Yuma all the way up to Black Metalish or Lake Havasu. To get to the detail of that, thanks. We have the green signal. It's suitable for both mobile and portable units. The yellow, when you can see it, and there's a few yellow spots in here, for instance, that's mobile only. And then red, which is this line between Quartzsite and getting up to Parker, insufficient signal. Because Cunningham Tower, although up, is not active. All right. If you get down to the real detail, and that's the leg in telegraph. Okay, that you can see there. This blue area around here is what's showing in the computer-generated coverage map. And this is the little, if I back up again, this is that little tiny chunk of red right here, but magnified. And you can see as you drive, there's basically the mountain range and telegraph is down here on the lower right hand, back a ways. The mountains here block the transmitted signal, and so you get red and then pick it up again as you go up. When you're in Google Earth, you can actually get down to the individual data segments, showing latitude, longitude, the signal strength, and again, this is for a specific bandwidth. This is all UHF right here. What we will have available is pick a region and then pick whatever bandwidth within the region you want to take a look at in detail. All right, so we'll basically have 10 regions. Each of the regions will have 3 bandwidths and then 2 versions of the data. One is just a pure track line with no individual data points, and then the actual data points, which is this version, will be available on the web. Now that speed of 97, it's not miles per hour, that's kilometers per hour. So, they really wanted to get it done fast. All right, and then another representation that is possible, we don't think we're going to post this on the web just because we haven't run all the data through it, and this is actually an Excel combo with Google Earth. But this shows all 3 bands at once, and the reception from telegraph, and then that middle zone where there is no reception, and then all the way through to black metal where it comes back up green again. But we can analyze this level of detail if need be, or if somebody really wants to get down to it. Again, actually it's a lot of data, and so you really couldn't load up one single version of Google Earth with all the regions at once, because by the time you get more than like 2 or 3 days into the testing, you've saturated most computer systems' ability to handle that much data in Google Earth. So it really is select the region, select the band, and then drill down into the detail. Basically, overall findings, the drive test data lined up with the existing coverage maps that have been supplied by DPS, so there were really no surprises in terms of areas that had coverage that we didn't expect it to, although that was the general direction. It was usually better. I think the DPS coverage maps were worst case maps, so that nobody would be surprised that they didn't have coverage when they thought they would. And then also just one of the observations during the test, the team noticed that there was an extremely low signal strength coming off Buell and VHF, reported to DPS, and they found, yes, there was actually a bad power unit on one of the transmitters. So, like I said, PSIC Ops will post the Google Earth files for all the regions and all the bands within each region, and they'll be available out there, and then primarily useful for ComEls and planning in terms of whatever, if an incident comes up, they can plan, get down to some detail, get some level of assurance they'll have AIRS as an available option. Okay, any questions?
Any timeline on when those will be posted?
I don't know. Probably within a week or 2, I think, Justin.
I think a key indicator of it is going to be how things shake out related to broadband here and the amount of resources we have. And hopefully within the next 2 weeks, and we'll be sure to notify the community and interested parties when the AIRS pages or websites updated.
I would caution not to oversaturate people with highly technical and complicated illustrations and drawings. I think the overlays work really good.
But because initially I was going real deep into it and going, whoa, wait a minute.
I don't know about individual data points, is not my view anyways, but I think even with the overlays, I think you need to be real clear as to what the 2 layers are. so that there's not a misunderstanding thinking that the predictions that, you know, the DPS made with their analysis are what was actually verified by the drive test. The drive test is actually just showing the highway corridor. Right.
I mean, it was heartening to say, oh, gee, there's a gap in coverage, and lo and behold, there's a gap in coverage. And what was nice in Google Earth, you can kind of turn around and look up at the transmitter and see that you can either see it or can't. So,
yeah, that's pretty cool. But I like the idea that it's a validation of what we already kind of knew, it looks like.
Right.
I think I would kind of keep it at that level.
No, that's a good point. That's a good point. Scott?
There are a couple of places where I think we observed hardware issues in the AIRS network. A couple of different drive tests in Pinal County where the results were not consistent between the two different days. One case they said, oh yeah, we've got good coverage here, and the next day said there's no coverage there, so there's obviously something broke someplace. Some of those things as agencies test the networks, and if they discover we got problems we need to go look at, then they need to notify the DPS Network Operations Center, and of course the SOP will put that on the go look at list to try and make sure that the system is operating as intended.
That's a good point. We'll probably re-emphasize that.
Right, and it's like this bad transmitter on Mule Mountain that we didn't find until we had a need to use it. Discovered, oh yeah, we got something broken. Now we go out and fix it. So we did.
Is the air system completely built out, or did this come up with spots that needed to be filled in, or additional equipment needed, or is this just a verification of what we have now?
This basically was a verification of what we have now. In terms of next steps, in terms of future build-out or AIRS Next Gen or anything, we haven't gone there yet with all this stuff.
Well,
But it is available if and when that happens.
I can from White Tank to Forsyth. Isn't that a known area that doesn't have coverage?
White Tank's out to about county line, milepost 70, does a pretty decent job. As you get past that, it gets kind of anemic. There is an intention to install an AIRS at Cunningham. However, there aren't enough cubic feet in the current building to do that. There's an intent to expand that facility there to a new tower and a new building, funding and time allowing. One of the things we did not show on this map, for instance, was the coverage we've added up at
Jacob Lake?
no, we turned up Jacob Lake since this, but we also have a
super, right.
that apparently has gone in and has worked real well. So there's additional coverage at this time. I know Yavapai County is talking about the possibility of adding a new site in the Prescott area in order to cover that. So that's kind of a long-term. Yeah, we know there are places in the state that don't have good coverage yet. Time and funding permitting, available space in the building that still something can grow.
And barring the broadband doesn't cover it for you.
Okay, you can all sit down.
How soon is that going to happen then?
After both of us retire.
That's right. Okay. Do you have a comment?
Dale Brown from Arizona State.
Oh, I'm sorry.
I know we had, this talks about I think we had talked about this before on the users of the system never knowing when there is a failure of AIR system. Since we operate on a statewide basis, in Colmel and Common Key Strategies, trying to plan events or trying to utilize the AIRS system on some of our incidents, it would be kind of a handy tool to be able to take a quick look out there before you start relying totally on AIRS and know, oh, okay, DPS is aware of an issue on White Tanks or Navajo Mountain, that the 800 component is transmitting not working. Would there be a tool that we can use as users to know what the knock is working on or what's broken, so that or that's in the pipeline to get repaired, so we don't assume that uses the AIR system that it's missing all the time?
Simplest question would be send an email to the NOC and say, is there a problem with the site? Rather than, I don't know that, and I've had a similar question come out of Mojave County in terms of how do we notify that at the county level that there's an issue in our county that's being worked on and has been resolved. And it's something we talked about doing, but it's not something we've ever had any time to implement. I know the emergency manager up there is maybe looking at putting in an email group within the county. So if there's something comes up, he sends a notice into DPS, we got it broke, we send it back, saying, okay, we're working on it. Hopefully we send him a final notice says, we've been there, we fixed it. Then he can forward that on to his own user group. I mean, it's obviously doable. It's just a matter of trying to find the time and figuring out who needs to be on that list.
Scott, does the NOC by any chance use any kind of a help desk application?
Yeah, they do, and that's one of the things that would allow us to do that, but we've just never had the time to sit down and implement the programming to do.
I'm just wondering if there's ways to report system outages and this report goes to the internet basically somehow that people can look at it.
If the mechanism would allow it to generate emails, but I don't think there's anything that generates information for a website, for instance. I mean,
If we look at current status of helicopters across the state, what's up, what's down?
yeah. It'd be nice to do, but it's a matter